Hi, I'm Don Crowley, and this is homework 2 for CSC 578. The first thing I'm going to walk you through is my changes in the cost functions. We had to change cross entropy, the derivative, and the log likelihood. Um, so you can see here for cross entropy, one of the things I did was I added a very small number to a for both the function and the derivative. This was to prevent some issues with possible divided by zero. For the log likelihood function, basically we wanted to find out where in the array y equals 1, um, and then put the log likelihood of a in that spot. For the derivative, it was kind of the same deal. I also made another adjustment for cases where a at that location is 0 or not to avoid divided by 0. All right, next activation functions. We have to do tan h. So tan h, pretty straightforward, just the function from the notes, from the slides in class. ReLU. Again, I made another adjustment here. I was running into some dividing by 0 problems with ReLU, and adding 0.001 to the function derivative seemed to help a little bit. Softmax was also another one. We just had to do the function for this one, and it was relatively straightforward again. All right, next adjustment we made was for an output layer. So default code just has the hidden layer all the way through. We needed to adjust feed forward. So you can see here that basically I ran through all the biases and weights up until the last one through the hidden layer here. Then I said that if there was not an output layer, just run the hidden layer again on the last set of weights and biases. If there was a hidden layer, then we run that. Let's see. If there was an output layer, we run the output layer on the last weights and the last biases. We also needed to update backprop for this one, so I'll walk you through that. All right, so the backprop code, again, it was kind of the same deal. So if there was no output function, we use the hidden function on the last two weights and biases. If there was, then so here we use the output function on the z value of the last weights and biases. All right, next we'll talk about regularization. So L2 was already baked into the code. We just had to add L1 to the code. First update for this was in the update mini batch. So let's see here. We needed to. So I said that if the regularization was 0 or nothing, we just use the weights and biases given to us already in the code. If the regularization was not L2, then we use the L1 weights and biases update here. Next, we also needed to update total cost for the L1. So if the cost was not L1, then I just use the formula, the default formula given to us. If the cost was L1, then we use this formula here. It's relatively self-explanatory. All right, the next thing we needed to do was dropout. So dropout, basically we are removing some of the nodes from our propagation. So we wanted to update feed forward first. So in the feed forward, I set up a so I set it up so if the dropout percentage is 0, we just run it normally. If we do have a dropout percentage, then I set a global variable called u1 list here, and that was where we were going to store the mask for choosing which nodes to drop out and how to keep track of them. So using this formula here, random binomial, the dropout percentage, made an array in the shape of the, the weights. Um, and I also set it here so we're not doing anything to the very last layer. So we have our mask here. We normalize it by dividing by the dropout percentage. For each run through biases and weights, we update our global U list with the mask, and then we calculate our A value by multiplying the hidden layer by the dot product of our weights times our mask with A added to B. So added to our bias. And then you can see again here, this is for if we have a hidden layer or not. Okay, so for dropout, we also needed to update backprop. Again, it was kind of the same deal. So if the dropout percentage was 0, we continued as normal. Otherwise, we wanted to backpropagate with our list of masks. So I set a counter here so we could so I could go through the list of masks for each bias and weight. We find our mask from the list, and then down here we add one to our location. So we keep going through the list. All right. So I think that's about it.